Compound angles, example 1. We're asked to express in third form sine 15 degrees. We don't know sine 15 degrees by heart, but we do know the angles 60, 30 and 45. We could write sine 15 as sine 60 minus sine 45. We could do it as sine 45 minus sine 30 either. We can see that there's a rule for sine A minus B. We have 60 minus 45 here. So we could express sine 60 minus sine 45 as sine 60 cos 45 minus cos 60 sine 45 using the rule that's given in the formula and tables book. Now we could use again the formula and tables book to look up the answers for each of these ratios. We might be familiar with the triangles though. So the triangle that has 60 degrees in it has sides of 2, 1 and root 3. And there's a triangle also with sides of 1, 1 and root 2 which have angles of 45 degrees. So we might be familiar with these two triangles. So we can see from this that sine of 60 opposite over hypotenuse is root 3 over 2. Cos 45 is 1 over root 2. Take away cos 60, which is half, and sine 45, which is also 1 over root 2. So this is our solution. We just want to neaten it up a little bit. We notice that the denominators are the same in both of these sets of fractions. So we can write it as root 3 minus 1 all over 2 root 2. Again, this could be the answer, but it is neater to write it with a rational denominator. So if we multiply above and below by root 2, we can rationalize the denominator here. So root 2 over root 2 is just 1. So we're just multiplying by 1. So root 2 by root 3 is root 6. Root 2 by negative 1 is root 2, negative root 2. And root 2 by root 2 is 4. And again, we'll just take out the calculator to check that this solution is correct. And we can see that it is. So sine 15 degrees is written in third form as root 6 minus root 2 divided by 4. In the second part of the question, then, we're asked to work out, evaluate tan 105 degrees. We'll do this in a similar method. We might write 105 as 60 plus 45. So we're going to use the tan A plus B compound angle formula here. So tan 60 plus 45 is equal to tan 60 plus tan 45 all divided by 1 minus tan 60 multiplied by tan 45. Again, we might know the solutions for each of these parts, but again, I'm looking at the triangle that's given here. So I can write tan 60 as root 3 over 1 or root 3. Tan 45 is 1 over 1, which is 1. Then I have 1 minus root 3 multiplied by 1. I'm just going to write this as root 3 because 1 times root 3 is root 3. Again, we'd like to rationalize the denominator. This is an answer, but it's neater written with a rational denominator. So the rule here is we multiply above and below by the conjugate of the denominator. So that's 1 plus root 3. We're effectively just multiplying by 1. So the number is the same, but it's expressed differently. So just expanding this, we have root 3 by 1 is root 3. Root 3 by root 3 is 3. 1 by 1 is 1. And 1 by root 3 is root 3. And in the denominator we have 1 by 1, which is 1. 1 by root 3, which is root 3. Negative root 3 by 1, which is negative root 3. And negative root 3 by root 3 is negative 3. So you can see there's some cancellations here. So our numerator becomes 4 plus 2 root 3. And we're dividing by negative 2. So dividing by negative 2, we can express this as negative 2 minus root 3. Again, we might take out the calculator just to check that this solution is correct. but we see that tan 105 is -2 negative root 3 in third form. So we can see that that's correct.